After watching the video about how do you measure the specific latent heat of vaporization of water, that means LV, I hope that you really know how do you find out the value by record down the correct data. Remember that when we want to find out LV, we need to find out Q over M. Q, we can use a kilovolt hour meter to find out the answer. Remember that we cannot use Joule meter because we need a huge amount of energy to boil the water into steam. So we need to use kilovolt hour meter, which can measure much more energy per unit time, okay, to find out the energy transfer to change water into steam. And we use this one, okay, the electronic balance, to help us to find out the mass of water. Remember, the mass of water change into steam, okay, change into steam. Now remember that when the water boils, the water change into steam. Then think about what will be the change of the reading from the electronic balance. Actually, when the water starts to boil, the value will be a certain amount. For example, we name it as Mi. When we continue to use the heater to boil the water, so more and more water change into steam, and then the reading of the electronic balance decrease, and then that is MF. Actually, the difference between Mi and MF, it should be the mass of water change into steam. By measuring how much energy transferred during such period, and then we can find out the specific latent heat of vaporization of water. So let us take example 4 to explain how to use the collected data. Remember that when we carry out this experiment, we need to find out the data, the initial mass of water from the electronic balance, and after boil, some water change into steam, then the final mass, okay, becomes 0.72. That means degrees. But when the mass of water change into steam is decreased, how do we find out the energy by using the kilovolt hour meter? We need to note, okay, about the working principle of the kilovolt hour meter as well. For the kilovolt hour meter, I try to draw it like this, very ugly drawing. And then in the middle, you can see here it has a disc. Once the energy is supplying, the disc is rotating. And then for 600 turns for the disc to rotate, it represents the energy given out, okay, by the heater should be equal to 1 kilovolt hour. So therefore you can see how can we understand about how do we measure the energy by using the kilovolt hour meter. First, Q equal to power multiplied by time. So for 1 kilovolt hour, that means the amount of energy should be equal to 1 kilovolt. That means 1000 volt. And then operate for 1 hour, which means, okay, it used for 3600 seconds. So actually 1 kilovolt hour equal to 3.6 times 10 to the power 6 joule. So think about if 600 turns, this one, 600 turns, equals, okay, or equivalent to such amount of energy given out, then for one turn, it represents how much joule of energy given out. So the energy given out for each turn of the disk of the kilovolt hour meter rotates should be equal to 3.6 times 10 to the power 6 over 600, because whenever 600 turns, it equivalent to such large amount of energy given out. So the energy for each turn should be 6,000 joule. Thus, you can see for each turn, the amount of energy equal to 6,000 joule energy. So when the kilovolt hour meter turns 41 rotations, which means 41 times 6,000 joule energy given out to, remember, for what purpose? To evaporate 0.1 kilogram water into steam. Such amount of energy try to evaporate 0.1 kg of water into steam. So therefore, you can write it down for 41 turns. Each turn represents 6,000 joule energy given to the heater to change water 0.1 kg of water into steam. So you can quickly find out the answer by using the calculator. Should be 2.46 times 10 to the power 6 joule per kilogram. So the calculation is not difficult if you understand how do you find out the energy by using the kilovolt hour meter. And also, usually, the experimental value usually higher than the standard value. What is the reason for part B? Usually, there are two reasons. The steam condense on the heater and then fall back into the cup, and then need to be a higher result. And the second one should be energy lost to surrounding. And remember that, I would like to emphasize. This one, it say that energy lost to surrounding need to be a higher value. This energy should be lost by what? By water, by heater, or by the kilovolt hour meter. Actually, it should be by the heater. The heater is very hot, and then it given out energy does not totally supplied to change the water into steam. So the energy from the heater directly lost to surrounding, and then cannot change water into steam. It need to be a greater Q that in calculation, and then when it over amp, it need to be a higher value. The second one is, I want to go back to this one. Okay, point number 1. When the steam, that means the water changes steam, heat the heater, the upper part of the heater, change back into water, and then fall back into the cup. So think about what is the final reading of the electronic balance, greater or lower than the true value. I repeat, if the steam change into water and then go back to the cup, think about the final balance reading, greater or smaller than the actual one. The answer should be the final balance reading will be higher than the true value. So overall, the difference between initial and final mass reading will be smaller. And then this M will be smaller than the true value, and then the overall specific latent heat of vaporization, the experimental value will be greater than the standard value. Now think about such logic once again. The balance reading will become greater, become greater, since water fall back, and then the final mass reading will be greater. The overall difference of the mass will be smaller, and there need to be a greater experimental latent heat of vaporization. Okay, the last one, part C. A student suggests adding a lid to the cup to reduce experiment error. Do you agree? Think about this diagram. If you cover the cup by lid, can you find out the mass of water change into steam by using the balance? The answer is no. Remember, when a lid really can reduce energy loss to surrounding, but more water will condense back into the water. In another word, that means we cannot find out the mass of water change into steam by using the. That's the end of the explanation about this experiment. Hope that you enjoy it. Bye bye.